Now that I've shown you this setup in action, it's time to actually go through the process of building it. So this file here is a bare bones IKFK ARM file. All it's got is the switch on it. So if I move the switch around, it's just a basic switch with the bind following in between. Now normally on a completed IKFK switch, when one system is active, the other one is hidden. But for the process of showing you how everything is following, we're just going to keep both systems visible at the same time. All right, so the first thing we need to do is to establish how the IK system will follow the FK system and vice versa. So the FK system here is actually fairly easy to understand how it will follow. Uh, since the FK icons here are based on rotations, what we need to establish is that the FK controls here are going to follow the IK joints here. So the rotation of these two IK joints are going to drive the rotations of the FK icons here. So that's pretty straightforward, and that's normally any other IKFK matching setup that you see. That's basically the premise of it. Now the IK system, how that follows, that's usually done with a series of locators because currently there really isn't anything for the pole vector to follow, and there really isn't anything for the IK control to follow. I guess you could have it follow the end of the FK arm here, but what we're just going to do is create a couple of locators so that these things can follow a little bit more precisely. So I'm just going to create a locator here. I'll duplicate it. So we're going to call this one left arm IK match locator. And we'll call this one left arm PV match for pole vector. So I'm just going to snap these to the exact position of the IK icon and the pole vector icon. There we go. Looks good. So now I'm just going to constrain these to follow the FK system. So the IK locator here, that'll just follow the FK3 waist joint, so the end of the FK chain of the arm. I'm going to select the FK3 joint and the IK match locator. We'll go to constrain there. There we go. And for the pole vector locator, I'm just going to constrain that to the root of the FK arm. So we don't necessarily want it to follow the elbow. We'll just have it follow the root of the arm. So FK1 waist, the PV match locator, constrain there. There we go. So now, if I move the FK system, you should see those locators, both those locators following. Perfect. So now we've established what is going to follow what. So now we can actually start the constraining process. So the first thing I want to point out here with this process is that we are going to do the setup one side at a time. So we are only going to start with the IK constraints here, and we are going to avoid doing the FK until we're completely done with the IK. That way we'll avoid any cycle whatsoever. Even if you run into a cycle, it may not cause anything to jump around, but you want to avoid cycles at all costs. So we're just going to start constraining the pole vector and the IK controls here. First, get that part of the setup all completely finished, and then we'll move on to the FK. So the first thing I'm going to do is I'm going to create a group for the IK control and the pole vector control. So I'm going to just group the IK control. Now the top group for the IK control has the values on it, so when I grouped the IK control, its pivot should automatically be located where the icon is, which is what we want. So I'm going to call this left arm IK match pad. And we'll do the same thing for the pole vector. Arm PB match pad. There we go. All right, so now I have the groups for the IK controls. So now we can go through the constraining process. So for the IK control here, I select that locator, and then I select the match pad here, and I'm gonna hit the constraint, just like that. And we'll do the same thing for the pole vector. Select the pole vector locator and the match pad on the pole vector icon and constraint there. There we go. So now the FK should be following the IK, or the IK controls now follow the FK. Cool. But what we need to do now is connect it to the matching attribute. So the first thing we need to do is create that matching attribute. So we go to Edit, Add Attribute. I'm just going to call this matching. We want it as an enum attribute, so just a simple 0 to 1. So I'm going to set the first part of this for the FK to follow the IK. Since the switch attribute here, when it's set to 0, that means the IK is dominant and it controls the bind. So I want the 0 part of this attribute to make the IK the dominant one, so that the FK will be following the IK is dominant, so there we go. So I'll set the second part of this enum attribute to IK follow FK. There we go. And we'll create add. Perfect. And I'm also going to create that reset attribute. In the previous video, we used that to get the arm back to this initial default position. So we're just going to call this reset. And we're going to set the first attribute to reset on. And we'll just set this one to off. There we go. So click OK. So now we have the two attributes that we need. So now we can go through creating the nodes to connect everything together. So what I need here is the hand icon that has the attributes and these two constraints that we just made. So I'm going to go into the node editor here. Get rid of the shape node there. All right, so I'm going to bring these constraints over here. And I'm going to bring the hand icon over here. So there are our attributes. So what I'm going to do is create a condition node. And we're going to set up this condition so that when this attribute is at 0, meaning where it is right now, so FK follow IK, when it's at 0, we're going to set the condition to connect into the node state part of this attribute. This is the crux of the matching that we're doing here, because the node state has this part here, waiting blocking. I've overlooked this part of the constraint for years now, and I didn't realize the power of the node state here. So when we set to waiting blocking, that means that the constraint freezes where it currently is and no longer calculates. This is how we avoid the cycle, because when the constraint is set to normal, like it usually is by default, that means that the constraint is calculating. So if you're calculating the IK to follow the FK and the FK to follow the IK, that's your cycle. But if we block at least one part of it, then you avoid the cycle because only one side is calculating. So what we are going to do is connect. First, we're actually going to name this. So I'm going to call this left arm. We'll call this IK match condition, because we're going to use this condition for both of the IK constraints here. So I'm going to plug the matching attribute into the first term here. I want to make sure this is set to equal for the operation. Good. So when I say when it's set to 0, so when this attribute is set to FK follow IK, what I'm going to do is set the color if true to 10. And what this is going to do, the 10 is kind of the number that's going to turn the node state into the waiting blocking here. So we're going to set this to 10, and we're going to set the rest of this to 0, because 0 is for the constraint, 0 is normal, which is what we want. So everything looks good here. So we're going to plug the outColor R of the condition here into the node state of the constraint. Now it doesn't show up here, so we have to find it by showing all the attributes. I hate that the node editor does that. It does that sometimes where when you right click on it to try and show all attributes, it goes into the right click menu and kind of removes it from the node editor. So now that we've got it back, we right click, go to show all attributes. Now we got a lot of attributes here, and we're looking for node state all the way down here. There it is. So I'm going to plug outColor R into the node state of that constraint. Now you see it's connected in there. Oops. That's not what I want. There you see. Now it's connected, and now you can see it's set to waiting blocking, which is exactly what we want to see. So we're just going to do the same thing for this constraint here, and connect it into the node state. There we go. Also set to waiting blocking. Now I'm also going to do a quick connection for the reset. The reset, this attribute here, I'm going to connect into the target of the constraint. So what this is essentially going to do is when I have it set to reset on, that means the attribute is technically 0, and it'll turn the target into 0, and which essentially will bring it back to its original position. So that's how we get the arm back into its original default position. So real quick, I'm just going to plug the reset into the target of each of these constraints. There we go. And you see it turned to 0. So that's really it for the IK part of this constraint. And now with these set to blocking, these aren't going to calculate. So now we can do the constraints for the other side. So make sure I set reset to off. So now we can do the constraints. Now, as I mentioned in the beginning of this video, we're going to set the FK controls to follow the IK joints here. So rotation to rotation. So first thing I got to do is create those matching groups, just like I did for the pull vector control, for the IK controls. So I'm going to call this FK2 matchpad. And call this one FK1 matchpad, of course. There we go. So we got our two pads, and now we just constrain them to the IK joints. So IK1 waist and the FK1 matchpad, constrain parent, and IK2 waist, FK2 matchpad. There we go. Constraint parent. There we go. So we got our constraints. And so now we can connect them into the setup here, just like we did before. Oops, didn't mean to select that. So we don't really need the groups in here, so I'm just going to remove those from the view. And we'll open these guys up here. So we're going to need another condition, just like we did for the IK setup. And you'll also notice that when we did the constraints, so we constrained the FK controls to the IK, there was no cycle. Even when, if I look in the node editor here, no cycles whatsoever. And you would know a cycle if you saw one. Script editor would freak out. You'd see the yellow bar down here at the bottom. So no cycle, which is good. That means a part of this is working already. So we're going to plug the matching into the first term, just like we did for the other one. I'm going to call this FK match condition. All right, and the only difference here between this and the IK is we're going to set the second term to 1, because since this is the FK part, we're doing it for this part of that enum attribute. So when we click IK follow FK, that's technically 1, so we want the condition to be set to 1. So when this equals 1, block the constraints. So first thing I'm going to do is I'm just going to quick connect the reset attributes into here while I have it. I don't have the long list of attributes here. I can just quick connect those in. And now I'll connect the condition to the node state. Bring this, oops, there we go, stop freaking out on me. So we'll plug the out color R into the node state here of both of these attributes. There we go. So you can see everything is connected. The FK part of the constraint is set to normal, and the IK part of the constraint is set to blocking. Exactly what we want. Everything looking good here. So now the matching part of this is pretty much done. We'll test it out just to make sure everything is working. We still haven't done the offset yet, but we'll get to that in the last video here. So let's test it just to make sure everything is working nicely. So right now it's set to IK here. Perfect. So let's move everything around. So IK seems to be working. FK is following properly. Looking good here. So now let's switch it over and see what happens. Matching IK follow FK. Now you're going to see one thing that's off here. See the IK system here is now shifted all the way over here. The bind and the FK systems here didn't move at all. This part actually worked just fine. Because you can see the FK is now in control here. The FK is working, and you can see that the IK actually is following, but the position is off here. Well, why is that? Well, the reason is when we deal with constraints and blocking, what the blocking does, as I've mentioned, is it essentially freezes the constraint where it is and it stops calculating. So if these pads here are essentially frozen, now that these constraints have become active, that's what I mean. When these constraints have become active, it now views this as the default position for where the arm is. And so the values on these controls are now added on top of this default position. So if you notice, when I zero these out, they actually snap right into the correct position. And you can see everything's following exactly as it should. Now, if you wanted to, you could just leave it at this and just remember to zero out the controls after they've snapped. The thing is, I don't really like seeing them snap like that. It kind of looks like it's broken. And as you saw in the first video, it looked a little bit cleaner. Everything kind of stayed put where it needed to be. You did still have to zero some stuff out to make sure the switch worked properly, but I think that was a small price to pay for everything looking pretty nice and neat. Um, so if I move the FK system around and everything looks good here, switch this back to 0, and you see what happens. Similar thing happens to the FK. IK didn't move at all. Everything looks good there. But you can see what happened with the FK. But if I zero it out, you'll notice everything kind of goes back into place and the IK is working. Looking good. So let's just test just to make sure that the reset is working, because you'll notice that even if I zero out all the controls here, the problem is this isn't the default position of the arm when we first created the arm. So that is also part of the issue with kind of blocking and restarting constraints, is it now views this as its default position. So what if I want to get this back to where I need it to? Well, that's where this reset comes in. So if I set the reset to on, and what I'm going to do is just click these attributes back and forth. So everything is back to its original position, and now I can turn the reset off. There we go. So now the matching looks like it's working well. So in the next video and the last video in this little series, we're going to just set up the offset to make sure that nothing is kind of freaking out or snapping into a spot we don't want it to.